This is Geometry Unit 2, Lesson 8 on Statement and Reason Proofs. Now, in geometry, a formal geometry proof is a series of statements in logical order. Now, what you're doing is you're making statements and backing up your statements in using a reason. So, you have to make your argument by making a statement, stating its reason, making the next statement based on that statement, doing its reason, and so on and so forth until you get to the conclusion that you're trying to prove. So, you have to know what statements are, and you have to know what reasons are. So, let's look at statements first of all. Statements should start with one or more gibbons. As part of a formal proof in geometry, you are given certain statements that you know are true based on your diagram. It's very important. They are facts that are true and relevant to the problem. When they are giving you gibbons, they're giving you a hint of what you need to use to work out what you want to have. Then, each statement should be a logical order. So each new statement should either be a direct conclusion from one or more previous statements. So if you have a previous statement, what can you conclude from that? Or you could go together with one or more previous statements to lead to a conclusion. Say you have two statements in together, they may add up to an addition postulate or something like that. So it should be in logical order as you go down for statements. And your last statement, the final statement that you make in your proof, is what it said to prove. So your last statement in your proof should say, I'm trying to prove this statement, and this is the reason it's true based on my argument. Now, the reasons go along with the statements. What's important about a reason is it comes from to explain why the statement is true, often by referring to previous statements. Now, what do you use for reasons? Well, we know that the given, but only if the statement was really given. You can't assume something. You have to be said in your proof somewhere, it has to say that this was a given statement. A definition can be used, but you must write it out. You can't just say right angles. You have to say right angles measure 90 degrees or something like that. You have to write out the definition. Postulates, by the name for the few that have a name, otherwise write them out. The postulates that we know, for example, that by name would be reflexive, substitution, transitive, addition, subtraction, multiplication, division. But any other postulates that we learn, you must write out. Right angles are congruent, for example. And previously proven theorems, we haven't done a lot of theorems yet, but we will be in the future. If you do have a theorem, you do write it out. You just don't say isosceles triangle theorem. You have to say what it actually means. So, when you are doing statements and reasons, the statements should be in logical order. Each one should be backed up by a reason. So now that we know what statements and reasons are in a proof, what do we actually do when we're doing a proof? Well, the first thing you should do is look at your givens and mark them on your diagram. That's what you know for sure. See what you know. So let's look at this example right here. I am given in this picture that angle KJM is congruent to angle NJL. That's what I know for sure. Now, we need to figure out what we're trying to prove. In this particular problem, we're trying to prove that angle KJL, and I'm going to mark it as a highlighter because I don't know how to prove it yet. KJL, which would be this angle right here, is congruent to MJN. So, working from this bigger angle, I want to end up with a smaller angle. So that's what I need to prove. So I'm going to try to plan what I need to do. Figure out how to get from what you know to where you need to go. So as I just said, we're starting with a bigger angle that we know is congruent, but we want to end up with a smaller angle. Probably what are we going to have to do? Well, usually going from a bigger angle to a smaller angle is using subtraction. So we are going to have to subtract something from that angle. Well, let's look at our picture right here. In order to subtract, we have to have two congruent quantities. We have one, but what would we have to subtract from this angle to get this angle? Well, it'd have to be this piece right here, angle LJM. Now, for this angle right here, if I want to end up with that one, I also have to subtract angle LJM. So we're going to have to subtract angle LJM from each angle. All right, so that is going to be my plan. And if I do that and subtract LJM from each angle, it should work. So Once you figure out your plan, see if you can write the proof. So let's try this actual proof. So my first statement is what I know. The only thing that I know about this statement, this proof, is that angle KJM is congruent to angle NJL. Now, we just know that because it was given. All right, so now according to our plan, we have to subtract LJM from each angle. But remember, with subtraction, what do you have to have in order to subtract? You need two congruent statements. I only know one congruent statement right now, but I actually want to subtract LJM from both sides of the equation, or from the, it's an equation, I guess. All right, so I have to say, what do I have to say to get LJM congruent to itself? Let's do that. Angle LJM is congruent to angle LJM. What property is that? That's the reflexive postulate. And that's used so that we have something to subtract from both sides. All right, now I'm going to write out the subtraction just to show that how we did it. When you get this, you can just put the conclusion as that, but let me do the subtraction to show how we did it. All right, so subtraction, bigger angle, smaller angle. So this is going to be angle KJM minus angle LJM is congruent to angle NJL minus angle LJM. And that equals, so I'm going to put or, if I take KJM, this angle right here, and I subtract out LJM, I am left with KJL. And then if I take NJL minus LJM, NJL is this angle here, minus LJM here, I am left with this angle over here, which is angle MJN. And what postulate did I use to do that? I used subtraction. I took the first two statements, number 1 and number 2, this one, and I subtracted them to get that one. Now notice this right here. This statement that I just made right here is my last statement. That is what I was trying to prove, so that should be my last statement in the problem. All right, let's see if we can set up one more example. We have given AMPL is a line, so this is a line that just tells you what's on the line. We have AM is congruent to EX, and we have EX is congruent to PL. That might give me something. Now what I'm trying to prove is that AP, which is this segment right here, is congruent to ML, which is this segment right there. Okay, so probably what are we going to have to do to get this to work? Well, I need somehow to get a bigger segment than what I have right here. So most likely I'm probably going to use addition, and we're going to have to figure out how to add the segments together. Now remember, you need two congruent segments in order to add when you do this. All right, so let's see what we can come up with for the segments. What am I going to have to add to get AP? Well, I have to get AM and MP together to add to get AP. And then I have PL to MP. Now my problem is, how am I going to get AM and PL congruent first? Because I need them to be congruent before I can add something to it. Well, what do we notice between this statement here and this statement here? Do you notice anything that's the same? What postulate is that? Well, that'd be the transitive postulate. So if we use the transitive postulate, we can say that AM is congruent to PL. All right, so let's start our proof, and then we'll finish it up in just a second. We have AMPL, where AM is congruent to EX, and EX is congruent to PL, and that's given. Now looking right here, we just said AM is congruent to EX and EX is congruent to PL. Using transitive, AM is congruent to PL. All right, and that's using transitive. Technically, you could say that's substitution too. That would be fine. That's using transitive. Now, I have AM congruent to PL by our diagram, but I want a bigger segment from a smaller segment, so I'm going to have to add. We have to use addition. All right, so see if you can figure out what my next step would be so that I can do addition. We'll go over this in class tomorrow.